When playing tennis, one of the most tedious and possibly most important tasks is to pick up the tennis balls. These tennis balls accumulate on the course during practice, and they present a tripping hazard to those who run up to them. When practicing by yourself, it would be convenient to have a robot pick up these balls for you. Normally, the players would pick them up before or after a break, but it'd be nice if we can get a longer break instead. It would increase the stamina of players because even pros get tired. Introducing the RollOnYou Bot, or RoyBot for short. It has a scooper that collects tennis balls as it travels a predetermined path. After traversing the court, the RoyBot will return to its home position and the balls can be collected by the user. In our prototype, the robot starts in the idle state, indicated by a yellow LED. With a button push, the robot enters the drive state, indicated by a green LED. It picks up the balls, and once it has reached the weight limit in the scooper, the RoyBot displays a red LED to show that it is full. The button can then be pressed to enter the load state, where there is a flashing yellow LED. The robot will go back to the idle state after loading and will be ready to drive again. Some additional behaviors are that we can exit the collecting state with a button push. This way, we can stop the robot immediately if it was turned on by mistake or if there is an emergency. In addition, the robot also senses distance in the forward direction and will stop if it senses an obstacle. On the RoyBot, the main actuators are the two motors connected to a drivetrain with PI control. There are also 3 status LEDs to show which state the robot is currently in. In addition, there is a button to let the user transition between states. On the front end, there is another motor that drives the arm connected to the scooper. We also have an ultrasonic sensor to detect obstacles in front of the robot. Finally, on the bottom of the scooper, there is a weight sensor to sense if the scooper is full of tennis balls. One of the main achievements was the geometry and fabrication of the scooper. In order to pick up the balls, we sanded the edges that would meet the balls and added a downward slope on the inside to keep the ball thin. In addition, we also used double-sided tape to make the balls stick to the scooper. We also did not have enough interrupt pins on our microcontroller to do position control for the front arm motor, so we added a physical stop for the motor instead. As long as we are not driving the linkage motor at full PWM, we were able to stall the linkage motor with this mechanism. Lastly, since the scooper arm must be larger to clear the chassis and drop in the tennis balls, we were able to successfully use fabric and create a net for the tennis balls. We were also able to add a backboard for the robot so that it could catch all the balls that went out of bounds.